Boeing is the world's largest aerospace company, but there's yet another challenge: how to win back the trust of airline passengers.
If it's Boeing, I won't fly. Imagine paying thousands of dollars to fly, only to find out your plane is practically falling apart.
The Boeing 787 Dreamliner was supposed to be one of the safest and most advanced planes in the world. Built with strong but lightweight materials and designed to fly long distances with less fuel, the 787 quickly became the pride of many airlines. KLM, one of the oldest and most respected airlines in Europe, proudly added this aircraft to its fleet, trusting it with thousands of lives every day. But beneath the smooth design and modern features, something dangerous was quietly hiding. How did no one notice it until now? And what does this mean for the future of flying? Stick around, because this story will blow your mind. The routine check that changed everything. It all started during a routine maintenance check at Amsterdam's Schiphol Airport. A KLM Boeing 787 Dreamliner had just returned from a long-haul flight, and as usual, the engineers began their post-flight inspection. This kind of check happens hundreds of times every week, often without any major findings. But that day was different. One of the engineers noticed something unusual near the wing root, which is the area where the wing meets the main body of the aircraft. At first, it looked like a hairline crack, barely visible to the naked eye. These aircraft are built with advanced materials like carbon fiber composites, and while those materials are strong, they also behave differently from the traditional aluminum used in older aircraft. What seemed like a minor line couldn't be ignored. Following protocol, the team ran a series of deeper scans using ultrasonic and thermographic testing. What they found made them pause. The crack wasn't just on the surface, it ran deeper, right into one of the internal structural joints. This wasn't just cosmetic damage. It was a sign of possible failure in one of the most critical parts of the aircraft.
There's a secondary problem where maintenance of the aircraft can be an issue. So the design might be fine, but there aren't enough checks going on. The aircraft aren't being maintained properly, and so that metastasizes the issue further.
Word spread quickly inside the hangar. The lead engineer called in specialists. More scans were taken, and over the next few hours, it became clear that this was not an isolated issue caused by some rough landing or weather stress. This was something that had been forming slowly over time. It was hidden, buried beneath layers of composite material and routine inspections. By the next morning, the aircraft was grounded. Not for a day or two, but indefinitely. KLM sent a full report to Boeing. Engineers from the aircraft manufacturer arrived within hours. They brought their own tools and their own concerns. The conversation between KLM and Boeing wasn't just about that single plane. It was about every other Dreamliner in the KLM fleet. If one aircraft showed signs of this deep fault, could others have the same issue? And worse, could planes in other parts of the world be flying right now with the same weakness buried inside them? The stakes were high. The Dreamliner had a clean safety record. It was trusted by major airlines all over the world. But if this crack, this hidden fault, was the result of a design issue or a manufacturing flaw, it could turn into a global crisis. No one wanted to jump to conclusions, but one thing was clear. Something serious had been found. And the deeper the investigation went, the more worrying the picture became.
Boeing CEO Dave Calhoun is meeting with senators on Capitol Hill today as the company's airplanes are coming under increased scrutiny following a string of troubling incidents.
When Boeing designed the 787 Dreamliner, it was a massive leap forward in aviation. The aircraft used fewer metal parts, had a lighter frame, and promised better fuel efficiency. But its most talked about feature was its use of composite materials that were strong, flexible, and resistant to corrosion. These materials were supposed to be the future, and for a long time they were, but that promise came with a hidden cost. The crack found on the KLM Dreamliner wasn't just sitting on a metal joint. It was hidden inside one of these advanced composite layers. In traditional aircraft, cracks often appear on the surface and can be seen, measured, and repaired. But with composite structures, the damage can begin from the inside. It can grow silently, even while the plane is in service, and remain invisible until it's too late. The engineers discovered that the internal frame near the wing joint had started to delaminate. That means the layers of composite material, which are glued together under high pressure, were beginning to separate. Think of it like layers of plywood coming apart. On a bench, that's a small problem, but inside a plane moving at hundreds of miles per hour, carrying over 200 people, it's a disaster waiting to happen. To make matters worse, this area of the aircraft wasn't supposed to experience the kind of stress that would cause such damage. That made the engineers nervous. Boeing's team joined KLM's inspection, and soon, both groups realized something chilling. The crack was forming in a part of the plane that wasn't supposed to crack ever. This wasn't the result of an accident. It was something that had likely been growing flight after flight, unnoticed. Engineers dug into flight logs. They checked weather patterns, landing conditions, and pressure readings. Nothing stood out. The Dreamliner had flown normally, landed smoothly, and passed every routine check. Still, the damage was there, hidden beneath the skin of the aircraft, inching forward day by day, completely invisible during standard inspections. This led to one big question. If this damage was developing under normal flying conditions, how many other Dreamliners could be hiding the same threat? Within days, KLM grounded multiple 787s in their fleet. Not because they had all shown signs of damage, but because no one could be sure. Pressure. Behind the scenes. Boeing asked other airlines to start internal inspections. Qatar Airways, American Airlines, British Airways, and several others began checking their own Dreamliners, especially the ones that had been in service the longest. Some airlines reported similar findings. Not identical cracks, but tiny signs of stress in the same region. That was enough to sound the alarm. A quiet investigation turned into a global concern. The aviation world was holding its breath. The Dreamliner had flown for years without a single major accident linked to structural failure. But now, that record felt like a ticking clock. Behind closed doors, meetings were held between airline CEOs, safety regulators, and Boeing executives. Everyone wanted answers. But there was another concern, one that few wanted to say out loud. If this fault had gone unnoticed for this long, what else might be hiding inside the world's most trusted aircraft? As the engineers worked, pressure grew quietly behind the scenes.
Other airlines using MAX 9 jets, including United, also reported finding loose bolts. United says it's now rethinking their partnership with Boeing.
Airlines don't just ground planes without a cost. Every parked aircraft means canceled flights, delayed schedules, and angry passengers. For an international airline like KLM, where the Dreamliner forms the backbone of many long-haul routes, even one aircraft sitting idle was a financial hit. Now, they had several, but safety always comes first. Or at least, it should. Boeing knew what was at stake.
Our top engineers and technical experts have been working tirelessly in collaboration with the Federal Aviation Administration and our customers to finalize and implement a software update that will ensure accidents like these never happen again.
They had already survived a major crisis a few years earlier with the 737 MAX. That aircraft had been grounded globally after 2 crashes revealed flaws in the automated flight control system. It had taken years, billions of dollars, and a damaged reputation to recover from that blow. A second major issue, this time with the 787, could be devastating. Inside Boeing, teams of engineers, lawyers, and executives scrambled to understand the scale of the problem. They were contemplating if this were a manufacturing defect, design oversight, or it be traced back to how certain aircraft were maintained. Initial reports suggested that the delamination might have begun near one of the fastening points that connect the wing structure to the fuselage. These points carry massive loads during flight, especially during takeoff and landing. Over time, tiny shifts, just millimeters, can add stress. And if the materials used during assembly were even slightly misaligned or imperfect, the damage could build slowly, flight after flight. That's when questions started falling on the supply chain. Boeing doesn't build every part of the plane themselves. Like most modern aircraft, the Dreamliner is assembled from components made by dozens of companies across multiple countries. One supplier builds the fuselage sections, another makes the wings, others provide bolts, fasteners, and sensors. The parts come together like a puzzle, often in separate facilities, before final assembly happens in the United States. It didn't take long before attention turned to suppliers responsible for providing critical structural components. Investigators began reviewing their quality control logs. There were whispers, not confirmed yet, that one batch of materials may have fallen just short of ideal standards. Not bad enough to raise alarms during inspection, but just enough to weaken under stress over time. Boeing didn't comment publicly on the supplier, but insiders knew the company was under scrutiny. Meanwhile, national aviation authorities started getting involved. The Dutch Safety Board worked closely with KLM, while the European Union Aviation Safety Agency sent teams to observe the findings. In the United States, the Federal Aviation Administration opened a review, and in Asia, countries like Japan and Singapore began quietly examining their own Dreamliners, just in case. This was no longer about one plane or one airline. It was about a potential pattern, a structural issue that could stretch across hundreds of aircraft flying today. And yet, Boeing remained cautious. Public statements were short, carefully worded, and filled with phrases like ongoing review and commitment to safety. But internally, the urgency was clear. If even one aircraft experienced failure during flight, the consequences would be tragic, and global trust in the Dreamliner would shatter. Some experts began speaking out. A few former Boeing engineers told aviation blogs that concerns about composite materials had been raised years ago, especially regarding long-term fatigue. They weren't blaming anyone directly, but they were raising flags. As one retired mechanic put it simply, when you build something to last, you have to make sure it actually will. Cracks in confidence. As investigations deepened, the problem was no longer just technical, but emotional. People were starting to pay attention. News outlets picked up the story, first in the Netherlands, then across Europe, and eventually worldwide. Headlines read, "The Boeing 787 Dreamliner's long history of safety concerns," and "Boeing grounds 8 Dreamliners over fuselage flaws." Passengers began asking questions. Flight attendants noticed the shift immediately. People boarding 787s looked uneasy. Some were hesitant to fasten their seatbelts. Others asked if they were flying on one of the broken planes. The calm confidence that had always surrounded the Dreamliner had been shaken. KLM responded quickly, releasing a public statement that reassured passengers their aircraft were being checked thoroughly and that any jet with even the slightest concern would not fly. Still, not everyone was convinced. Bookings dropped slightly. A few customers even switched to different airlines just to avoid flying on a 787. Other airlines felt the tremor too. British Airways, Qatar Airways, and United Airlines, all major operators of the Dreamliner, began issuing updates about their inspection schedules. Even when no issues were found, they still had to explain their actions. This was about trust, and trust is fragile. At the heart of it all, Boeing faced a dilemma. On one hand, they didn't want to create panic. On the other hand, staying silent could be seen as hiding something. So, they tried to walk a tightrope, cooperating with regulators, supporting the airlines, but avoiding too much detail in public. But details eventually began to leak. An aviation analyst revealed that the specific area where the fault was discovered between the mid-fuselage and wing join had been flagged before during production delays years ago. Back then, it wasn't seen as dangerous, just complex. But now, with evidence of delamination, everything from that earlier warning took on new meaning. To make matters worse, Engineers from 2 airlines reported tiny gaps called shimming issues in other 787s. Shims are small fillers used to close spaces between parts during assembly. If placed incorrectly or if they shift over time, they can cause stress points. Boeing had known about shimming problems in the past, even pausing production for months to fix them. But no one thought those minor adjustments could lead to something as serious as this. By now, the investigation was growing in 2 directions. One group focused on materials like the composites, adhesives, and layering methods used during assembly. The second looked at load stress, like how everyday flying puts pressure on joints, especially after hundreds or thousands of takeoffs and landings. The conclusion was not yet clear, but one thing stood out. This was not a one-time error. It wasn't caused by one technician or one bad flight. It was something that had quietly built up over years of normal service. Inside Boeing, some voices began pushing for a full fleet inspection order, not just for KLM planes, but for every 787 flying anywhere in the world. Others hesitated. Such a move would disrupt global travel. It would cost airlines millions. It could damage relationships. Meanwhile, pilots kept flying, cabin crews kept serving, mechanics kept checking. But underneath it all, people were watching closely. And not just in the industry, because passengers were paying attention. Travel bloggers started warning readers. Online forums buzzed with questions. Families about to fly to see loved ones began to second-guess their tickets. The Dreamliner, once seen as a wonder of modern travel, was now under a shadow. The fault inside one aircraft had exposed more than just a crack in the frame. It had exposed a crack in the confidence of millions. The race to fix the fault. With the fault now public, the pressure was on to act fast. Aviation regulators around the world moved quickly. In Europe, the European Union Aviation Safety Agency issued emergency directives, ordering immediate inspections of all Boeing 787 Dreamliners. The Federal Aviation Administration in the United States followed suit. KLM and other airlines scrambled to comply, pulling dozens of planes out of service to undergo thorough examinations. For Boeing, this was a crisis unlike any they had faced in recent years. Engineers worked day and night, examining every detail of the fault. They tested samples in labs, used computer simulations, and reviewed every manufacturing record. They needed to know what had caused this fault to form, and more importantly, how could they stop it from happening again? Early results pointed toward a combination of factors. The materials themselves were strong, but required precise handling. Even tiny errors during assembly, like improperly placed adhesives or small shifts in layers, could weaken the structure. Over time, the constant stress of flights like takeoffs, landings, turbulence would worsen these hidden weaknesses until they became visible cracks. Boeing's design teams began working on a fix. That's not all. Unlike a simple replacement of parts, this problem meant changing how the planes were built and maintained. They had to redesign some internal joints, improve quality controls at suppliers, and develop new inspection techniques that could detect damage before it became dangerous. Meanwhile, airlines had to cope with grounded fleets and disrupted schedules. For KLM, this meant canceling or delaying dozens of long-haul flights. Passengers were rebooked, compensation paid, and crews reassigned. The financial toll was heavy, but safety came first. Public relations teams also went into overdrive. Boeing and KLM issued regular updates, trying to reassure the public that every step was being taken to keep passengers safe. Still, the damage to confidence was clear. Some travelers chose other airlines, while others postponed trips altogether. The aviation industry learned a harsh lesson. Even the most advanced technology can hide unexpected dangers. The Dreamliner's fault was a reminder that innovation always carries risks. But it also showed how quickly the system could respond as engineers, regulators, airlines, and manufacturers worked together to find solutions. Inside hangars around the world, Mechanics developed new skills and tools. They learned to spot subtle signs that had once gone unnoticed. Pilots received updated training to handle emergencies related to structural issues. And engineers studied every flight, every landing, looking for clues that might prevent the next hidden fault. The race was on to fix the planes already in the air and to make sure future models were safer than ever. As the news spread, passengers began to worry. Flying on a Boeing 787 felt uncertain. Social media filled with anxious questions, videos explaining the fault went viral, and forums buzzed with debates. Some travelers shared stories of canceled flights or changed bookings, while others openly admitted they felt uneasy stepping onto a Dreamliner. Flight attendants and pilots faced the challenge of calming nerves in the cabin. They knew the planes were being checked thoroughly, but they also understood how fear could spread quickly. Training sessions now included how to talk to concerned passengers without causing panic. Airlines worked hard to reassure everyone, emphasizing that the planes were grounded as a safety precaution, not because they were unsafe to fly. Meanwhile, the fault discovery sparked debates in aviation circles worldwide. Industry experts questioned whether the push for lighter, more fuel-efficient planes had come at a cost. The Dreamliner's innovative materials were supposed to be a breakthrough, but they also required new ways of maintenance and inspection, which were knowledge that the entire global industry was still catching up to. Some critics argued that regulators had been too slow to act. They wondered if more aggressive inspections should have been in place years ago. Others pointed to the challenges of managing a vast international supply chain, where thousands of parts are sourced from different companies around the world. Ensuring consistent quality across all these suppliers was a huge task, and even small mistakes could create risks. In the end, the incident showed that even the most advanced machines depend on careful attention, constant vigilance, and above all, the people who build, maintain, and fly them. The skies may be filled with technology, but it is human care and expertise that keep them safe. What would you do if you found out your plane had a hidden fault? Would you still feel safe flying on a Dreamliner? Let us know in the comments section. Remember to like, share it, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.